Hey math kids, we just have one more to go through in this section, and it says suppose that we have this where k is equal to 0 and b is in between 0 and 2 pi. We need to find k and b. So what we're going to do first, we're going to use our compound angle identities to kind of rewrite this side of the equation. So we're going to say k cosine x, cosine b, and if you're not sure what I'm doing, make sure you watch the first part of this video where I go into more detail about what's going on. Now I'm going to distribute the k cosine x cosine b minus k sine x sine b. Alright, now k and b are both coefficients, or both constants. And so we can think of like this and this multiplied together as a coefficient, and we can think of this and this multiplied together as a different coefficient. And so if we compare that to the coefficients of these things, when we have the cosine that has the x right there, we can say that negative square root of 3, or actually let's not do negative, let's just do square root of 3, or no, negative, what am I doing? Okay, so negative square root of 3 is equal to k cosine b, because these are the coefficient together, and then this is the coefficient of that, so they must equal each other. Okay, similar thinking, we're going to use negative k sine b, and we're going to use just this, which is a 1, and we're going to use that to try to solve for one of the variables. So what we can do, we can take this over this, and the k's will cancel, so we'll only have b's left over, and then the sine equals 1 and the cosine equals negative square root of 3. So if we simplify just a little bit, these k's go away, and then we're just left with like negative tangent b, because sine over cosine is tangent. So we have negative tangent b equals 1 over negative square root of 3. Now, because both sides are negative, we can just divide both sides by negative 1, and those cancel. So if we do this, we get square root of 3 over 3 let's see, and if we want to know what that is, we use our unit circle. So I'm just going to look at it. Let's see, if we go right here, we get square root of 3 halves, comma 1 half. And if we were to take the y over x of that, we would get 1 half over square root of 3 halves. 2's would cancel. We're left with 1 over the square root of 3, which is this, and that happened at our pi 6th mark right there. Now, it's also going to happen down here, which is going to be, oops, I drew that kind of bad, like this. So this is also pi sixth, which it's pi plus pi sixth. So pi plus pi sixth, that's like saying 6 pi over 6, and so that's 7 pi sixths. Okay, so this value happens at pi sixth and 7 pi sixths. So those are our two possible values for b. Now, they may not work. We have to test them. Now, let's see. I'm going to get rid of some of this work. Okay, so if we let's plug in this one first. If we plug in pi 6 to this one, we're going to get negative square root of 3 equals k cosine of pi 6. On our unit circle, pi 6 is the first one. That's square root of 3 halves over 1/2. This is the x value, and so we get k times square root of 3 halves. If we multiply by 2 over square root of 3, 2 over square root of 3, these cancel, we're left with k. Square root of 3 cancels square root of 3, and so k equals negative 2. Now, right here in the beginning, it said k had to be greater than 0, so we're going to reject that as well as reject this. So now we're going to do something similar. We're going to use that same equation, but this time we're going to plug in 7 pi 6. So negative square root of 3 equals k cosine of 7 pi 6. Now 7 pi 6 is right here, which goes to here, which goes to here. So this is square root of 3 halves, 1/2. Over here would be negative square root of 3 halves, 1/2. And then down here would be negative square root of 3 halves, negative 1/2. So the x value is going to be negative, so k negative square root of 3 halves. Then we want to multiply by the reciprocal. These cancel, and we're left with a positive 2 for k, and so we have our two answers. K is equal to 2, and b is equal to 7 pi 6. If you need additional help, please come to Math Lab. Until then, calculator.